Let's talk about fraction multiplication. First off, remember that there's a geometric view of multiplying two numbers together. So, for instance, 2 times 3. Let's start with 2 times 3. One way to view this is to go up 2 units. You could also, of course, go over 2 units, but then the 3 should be the other side of the rectangle. So, I'm going to go 1, 2, 3. You build this rectangle right here, and that shaded region. How big is that? You see in this particular example that is 6 of these unit squares. So it's an area of 6. You could think of each one of these squares as actually being a square-shaped pizza, and that's the view we're going to take in just a moment. But 2 times 3 is 6 because you end up collecting 6 total, 6 entire pizzas. Of course, if something like if something like this is a pizza, then of course, that's a half pizza right there, that shaded part. You could also say that this is a half pizza, and you could say things like if I were to cut twice and I'd have 3 equal sized pieces, and I could say, that shaded part. Sort of a weird shaped piece of pizza, but you could call this a third of a pizza because there are 3 equal sized slices, and you take one of them. So we're going to try to do the same thing as earlier when we dealt with 2 times 3 and had this rectangle right here. We're going to do the same thing, but because we're not going to go travel 2 units up and we're not going to travel 3 units across, we're not going to need nearly as much room to do this because I'd like to the example, let's see, how about 1/4 times 2/5, just as an example. So 1/4. I mean, the thing is, when we looked at 2 times 3, we had to travel 2 units up, all the way up here. We don't have to travel nearly as far because we're only going 1/4. So let me zoom in. Right, let me actually even zoom into this copy I have in the lower lower left here. So if we were to deal with, zoom out one step, if we were to deal with, again, I believe 4 times 2/5, then along this way, I'd like to represent the 1/4. Now, traveling all the way up to right here would be 1 unit. That's too far. Traveling up to here would be a half. We don't need that far. We need a fourth. Actually, tell you what, it'll be easier if I just draw in my 3 slice marks. So I run my pizza cutter this way. And so 1/4 is represented by this. Let me shade that in very well. Then, right, you can check that this is 1/4. This would be up to here would be 2/4, up to there would be 3/4, and up to here would be 4/4. So we've sliced 3 times, and that gives us kind of 4 strips of pizza right here. Well, erase this on the second one, third one, and a 4th slice of pizza. So of these 4 shaded slices of pizza, we're just taking the bottom one. Same deal with 2/5 right here. So we should cut this bottom line segment along here. Again, if we were multiplying by 2, we'd go all the way up to here, but we're not multiplying by 2, we're multiplying by 2/5, which is a tiny fraction. It's just part of the number 1. So we should make 4 equal sized cuts, because then this way, if we run our pizza cutter there's 1, 2, 3, 4. And let me try this in another color, but we'll see, and I'll erase this in a second. There's 1, 2, 3, 4, 5. So if we ignored the slices in the other direction, then there would be 5 equal sized slices of pizza, and then 2/5 would be, well, starting from here, there's 1 and 2. So we're mixing a couple ideas. We haven't really brought up the pizza yet. I'm just trying to say that this is 1 unit across, and so what's depicted in blue above that far is 2/5, right? That's a fractional part of the number 1. So we've got 1/4 right here. We've got 2/5 along here. And so, just like earlier, we were dealing, with multiplying together to multiply, we built a rectangle with the 2 side lengths. Now we have a side length of 1/4 represented right along here, and along here, and we have a side length of 2/5 represented this way and this way. Now we go back to the idea of pizza. Recall earlier, let me use this other box right here. We had talked about how something like um, cutting this in half and shading one would be one slice of pizza. We could also do the same if I just cut this way. Then if I just took, now there's four slices here, and if I shaded just this one right there, well then that would be 1/4 of a pizza, right? But in the particular example we're looking at right over here, let me switch colors back to blue. So in this example right here, you'll find a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15, 16, 18, 20 slices. In 20 slices, that'll be the denominator, right? The number of slices of the denominator. And of those 20 slices, should I shade in this rectangle back for that area model of multiplication? And the number, so this is the rectangle. Again, it's 1/4 in one direction, 2/5 in the other. So the area of this rectangle is clearly less than 1, which is way out here, the big square. But now viewed as pizza, out of the 20 slices, 2 of the 20 are shaded. So what we end up getting here is that 1/4, excuse me, let's see, what we end up seeing is that 1/4 times 2/5 right here is going to equal 2/20. Of course, um, in this particular example, uh, this fraction reduces. We could think of this as 2 times 1 over 2 times 10, and that'll allow us to cancel the 2's. We'll be left with 1/10. And in fact, you could view this particular pizza as being only in 10 slices if you glued 2 slices that are next to each other, and you're going to take one of those. But not to worry about that. The key thing about this is just to say that when you are multiplying fractions, this is just an example. So this example, it really doesn't depend on using the number 1/4, 2/5, and so on and so forth. So what I'd like to do is zoom out for a second, and basically, again, I'll just leave this fraction right here, 20ths unsimplified, to illustrate the overall point. Right? And if I zoom out a little more, then what would a general explanation of this look like? Again, remember that for two formulas, you really don't want to plug in numbers. That's not going to be considered giving a generic argument. So what you really have to do is really, well, if you're on a blank sheet of paper, draw a square. And that square represents your entire one big old pizza. But then the idea behind understanding A over B times C over D, notice there's a B and a D, so the denominator numbers, they don't even have to be the same at all. Is so A over B could represent, just cut, in your diagram, it doesn't have to be perfect. Instead of actually picking a number and being definite, instead of creating like 4 equal slices, the whole idea behind these lines is to say, look, I'm just slicing the same amount each way, and you could take maybe the bottom, some number of these slices, and write something like take A of horizontal strips. And then same thing to represent C over D. What you can do is just cut the other direction, somehow. And again, the lines that you draw vertically, I'm not trying to suggest you make the picture so perfect as to have the vertical lines evenly spaced apart. That's what's going to happen in a specific example, but this is just meant to be a more generic picture. And then if you take some number of these slices, I'm choosing the ones on the left. You could choose the ones over here on the right, but I chose the ones here on the left just to kind of match the picture I have there in the corner. And then this you could say is take, where what we're doing is we're taking C of the vertical strips. So this cutting things in this way ends up helping us get a representation of that fractional number for this side length and this side length. And then Remember the area multiplying these two fractions we were being doing is that multiplying is represented by the area of this rectangle, which is clearly less than 1. It should be less than 1 because you only took some side of a pizza and some other side of a pizza. So as an area, we have an area less than 1 because it's less than this full square here, of course. But now the deal is to think of how much area do we have precisely, and that's where thinking of pizza comes in. Because what you have in the diagram is you have a total of b times d slices of pizza. They're just square or maybe rectangular slices of pizza. And then the number shaded or the number eaten shaded are 8.